after quite a bit of pissing about. It's took longer to get a DTI mounted which I can use, which is not fouling anywhere, than it has to actually set the angle. So each small division is half a thou. So I would have said that is within plus or minus half a thou. I would have said it's probably within the tolerance of the slides on this top slide. That's the tapping size for 3/8 Whitworth, which is 5/16. The piece of shaft is one from the scrapyard. It was the same, it's the end of the shaft that I made the vice screw out of, with the left hand trapezoidal or acme thread. I think it was a trapezoidal in the end. It machines nice. It's not the easiest of stuff to machine, but it's that last bit was a bit snotty, grabby and all sorts. Anyway, so the next job's stuff the staff, tap up, rough this down to approximate dimensions, and then turn the taper. And that up towards the shoulder. There's a bit of variation between the various ones I've got. That's an older one. A bit ridgy. And just start to see the end of it on the tang hole. The threaded hole in the end is for a removable tang, which I've got to say I was surprised that it was 3/8 Whitworth. Yeah, bit of a Polish, and Bob will be my uncle. On the ridges, so we'll give them a bit of a tickle off, and bring it back when we've done some polishing. We've only just gone over it with a 120 grit, and we're pretty good all the way down. So I'll give it a bit more with a 180, and we'll probably call that done. That's the last print. You can actually feel when it's right. It just goes on, and I mean, I'm not, and that's already taken a lot of pressure to turn that. It's a shitload better than the tail stock on this. You can, I'll put some ink on and then you can see. That's stuck. It's good enough for me, that. As I say, it feels better than most of the other fits I've got on them. So that can come out now, because as I say, the rest of the machining can happen with that bit reversed. Once cutting off, job's a good one. Get on with making it. So I'm only making 2, I've decided, because I've got another couple of the purchase blanks. But that was a new exercise for me. I've never turned a Morse taper before, and slightly less apprehensive about doing one again. The only problem I've got is as I mentioned, the top slide on my lathe will only move that distance, so I can't do a Morse taper 3 on account of it being a longer taper. I've got to offset the tail stock or make up some kind of taper turning attachment. Or I have seen an attachment you stick into the Morse taper your tail stock, and then that gives you the offset. What I haven't seen is how it actually holds the adjustment to be parallel with the lathe bed, because obviously if it drops down, whatever adjustment you make is going to change, so it's got to go in and stay the axis of movement that way has got to stay the same. It can't rotate round, otherwise your offset's going to change, and my tail stock's not up to much. So right, bring you back when we're doing the next bit. Well, we're taking a break from the gear cutting exercise on the basis of I'm waiting for a backing plate for me chuck, blank that I can machine down. So given that I've got the excessive wear in the clapper box, I've elected to make a sort that out. I've ordered a tapered reamer, which is on its way, and whilst I'm waiting for that, I'm coming up with a way of making up the taper pin. And the taper pin is a 1:48 ratio taper, so that's an inch reduction in diameter over 48 inches of length, or a thou per 48 thou. And I can't achieve a 6-inch long length of that taper using my topslide. I haven't got a taper turning attachment, so the only other way of doing it would be either to offset the tail stock, which on my lathe is a pain in the arse to get set up and do, and then get it set back to square, or come up with an arrangement which would enable me to make that offset without adjusting the tail stock through an additional piece of kit. Or I could just make a taper turning attachment, which is quite a long project and maybe one for a later date. So what I'm going to do is cobble together basically a facility to use a Morse taper in the tail stock, and then give myself a second centre that I can adjust the offset from. Now you can buy these with a simple screw adjust. I think they're around about 65 quid, which seems a shitload of money for half a dozen bits. And given that I've got all the gear and clearly nothing else to do, I thought I'd make one up. So, having recently manufactured my Morse taper, that's the screw-in tang, that'll go in the tail stock, and then I'll turn the end of that to fit in to the arse face of that, into which I'll cut a dovetail slide, and then its mating piece will slide on that, into which it'll have a small fixed centre. I'm not going to mess about making it interchangeable, not at this stage, but I'll make that the movable piece. This thing will be about 2 inches long, it's not very long. And then for the adjustment, looking through me bits of various kit, I'd got this, which is a Moore and Wright micrometer head. It works like a depth micrometer. So whereas a normal micrometer you unwind to increase the gap, this one you actually wind it in. So the plan would be to have, if that's fixed on the tail stock, to have an end plate where this goes through, small gib with some adjusting screws if I don't get the fit very good, and then you wind that in to jack the offset piece with the centre out. The only problem would be is if you go too far, you've got to wind that back, shove it back and start again. But what I'm thinking is that will enable me to have quite an accurate, that reads in thou. Come on, it's a micrometer head, you know what they read like. I'm not going to be working to 10th of thou doing this. So that'll give me a thou reading. If I then couple that with a DTI running backwards and forwards along the carriage, it should be as accurate as I need it to be. So the only issue I've got is the slight concern that given the wear on the clapper box, that I'm going to be able to achieve a decent dovetail, but it is only small. I am only going to be taking light cuts, so that's the plan. Once I got this lot marked up, I'll bring you back. Right, I've roughed them down to size on the shaper. Marcus, you'll be pleased to know I've managed to pick myself up an old pair of Mitatoyas. They're well worn. I can just about see daylight this side of the thing, so they either want relapping in. But to be honest, all I want them for is marking out, so that saved me decent metric set. Just as an aside, so this, I've took off 1/4 of an inch on this, and I think 3 passes. So we'll see how it comes out. So that's 2 inch and 10 and it's not quite 11, so let's call that 10/8. Can you see that? There's something like 2/10. I mean, I know it's only 3 inches, but I've been reading some absolute shit on the comments on other channels about why people are using shapers. They're rubbish, they're not accurate. They're as accurate as the ways are. You take the time to refurbish it and you get a decent result. Helps if your clapper box isn't wobbling about. Right, so that'll form the male, that'll form the female, so that'll then slide, well, it'll be that way around, in and out. I'm going to cut the male first, so that then when that's clamped into the vice jaws and I'm cutting the females, I can keep checking that for fit. Whereas if that's clamped in, it's a lot harder to try and get that over it and tell what's where. At least that's the plan. I'll bring you back once I've worked out how I'm going to do it and once I've marked it all out. So that's the female dovetail marked out. I'm just going through working out what weapon of choice I'm going to use on the shaper. That was my initial plan. Now I've got to get down to cut that included angle of 50 degrees. So I figured I can hang this, rotate the bit round a bit more, and then basically a bit more, and then you start knocking here or knocking here, so you increase that, and then you've got an awful lot of tool hang out. So I scrapped that idea and then started having a look through my other book of weapons, and I'd got some these are lathe turning bits that I used to use on my other shaper. So obviously the corner's no bleeding good. I mean, that's about best part of what, 3/8 of an inch radius. But I've got a left and a right one of these, so I've repurposed them to give me that. I took a lesson out of I think it was Greg's channel, The Shed, which I'll put a link in below. He basically does most of his roughing work with a slitting saw on an angle grinder, because that was quite a bit of a material for my little grinder to shift. But that now gives me the option of initially you move that centre section and then you work in then with the tool head moving at that 55-degree angle and work our way down. So I've just got a bit of refining to do on the edges. The lighting's not brilliant, and put a very small radius on the front nose. They are set, let's see if I can get the lighting a bit better. They are the pre-ground these with a rake suitable for turning at the lathe. So the small area here, which is basically the bit that's going to be doing the cutting, I'll take across so that it's more flat with the angle, so there's no back rake which prevents the tool digging in. This is the cutting edge here, just around this area, and then this bottom section here. The rest of it are clearance. So that's the plan. So I've got a bit of fettling up to do on the tips, and then stick the block in the vise, take out the middle section, and then work it. Well, I was all intent on videoing me cutting this dovetail. Truth be told, it's been a pain in the arse. Mainly because of the play in the box. I've took the pin out, pushed the reamer through it, and I've actually enlarged the small end by nearly 1/8 thou now, and it's much better than it was, but there's still enough play in it to cause me all sorts of problems. So that actual cutting of it has taken an age. I mean, it would be what, if you said 10 minutes including setup to do it on the vertical mill, that's as long as it would do, and you'd probably do the other side in 2 minutes after that. Whereas this has took me a couple of hours messing about. So yeah, I don't know what I'll be able to video. I want to get on with it now. I'm going to flip this round, do the other part. I'm not going to piss around with the setup because it's set now. So the actual way I'm going to end up machining it is cutting them all from the same size, using the same angle setup, and we'll see how it goes. But just grinding the tool to get a sort of 50-degree angle, so I've got a couple of degrees either side, has helped. But yeah, silly things like, because of the play, it's springing back into the cut at the start, sorry, into the taking up the tolerance at the top and slack at the start. Then it gets to the end and the pressure comes off. The clapper box has got enough movement in it that it's actually snagging on the way back. I've tried every different way of the angles, but yeah, it's been educational and yet frustrating. So I'll flip it round, do the other side, and then see if I can get some video of doing the female. So the camera fell off, so that's another camera mount that doesn't work very well. See if we can carry on. So each index across is between 15 and 20 thou, read off a dial indicator. So I'm bringing the work in 15 to 20 thou, and the tool is advancing down each stroke by between 2 and 5 thou. Got a little bit more to come off, but it's getting there. But I don't know whether you can tell from there, but you see how, where's my finger, that bottom edge isn't flat to that. That's because of the play in the clapper box. Having cut this one across, and I'm coming down to the same point each time on the dial, there's enough play for it to be for the tool to be just lifting out a little bit each time. So I have to go back and do a clean up pass. Anyway, I'll bring you back when we've cleaned it up. Oh, sorry for the contrasty image. It's very, very sunny out, so we're not used to these conditions. That's the clean up done, and the way I get the height, it's a quarter of an inch from there to that. So I've basically got a spacer, and I set the tool height off that surface, which is always going to be related to that surface, and that's what I did for both sides. So that can come out, and we'll stick the other piece in and have some joy with that one. We've fitted the Morse taper onto the back of the main block. That's a press fit, and I've put in a grub screw on the underside, which goes half and half into the hole. Just setting it all ready for drilling the top side of it, which will give me the position for the centre. All I'm really bothered about is making sure that the centre height, because this thing will always go in with this being at the top, because it's got a T for top. I just want to make sure that we're about level. And broken bubble. It's not a machinist's spirit level, but as I say, it's not that critical. Just want it. That'll do for me. So centre drill it out, probably do something like 20 mil or 3/4 of an inch, and then make up a little hardened steel 60° fixed centre. And I've made the backing plate there that will take the micrometer head, and then these are fitted with little grub screws which I can lock them down to lock it up once I've got the setting. Bit of progress. Right, so we're making the dead centre. I'm pretty sure this is a silver steel, or 01, or drill rod I think they call it over in the States. The reason I'm not 100% sure is it came in a bundle of alleged silver steel. All the indications are right, but we shall see. Anyway, the idea is to basically turn it up, and then I'm going to heat treat it, or attempt to heat treat it. I was going to do it in the collet chuck, because I've got to take it down to 5/8 diameter and then spin it round and put the 60° taper on. Problem is, it's too bloody big for me ER32 collet, so I've got to take it down to fit into that. So the first job is going to be take this end down to 5/8, then to take the chuck off, stick the collet chuck on, and stick the 60° taper on to the other end. Right, we've reversed it round. We're now cutting the 60° taper. And it's well chilly out. That rattle's bugging me now. Sounds like a pulley's loose on the shaft. I'm not going to an absolute point on the end because it's just one less thing to jab my hand on. Give that a little polish and get ready to do some heat treating on it, which is nice because it'll warm us up. I'd have said that was cherry red. So now we'll find out if it was actually 01 steel or not. My quench bucket's the chickens for water and it's got snow in it. Oh well. So we'll clean that up and job's a good one. Well, because I just watched Steve Summers doing some bluing, I thought I'd have a go at bluing it. Doesn't seem to take a lot of heat, does it? I don't know how much of that will show up on the camera. Let it cool down and I'll bring it back. Well, I'm quite happy with that. That's my first attempt. Next time I need to move the heat around a bit more. Anyway, just got to put it all together, mount the micrometer and get on with turning this pin. I'm just investigating the rattly noise on the lathe. Whether you can see in that pulley, you see where the key is. Where the hell is it? It's at that position now, so it should be straight out with us. And then if you take a look, so that's where a grub screw sits, and it's 90 degrees round from where the keyway sits, so something's not right. There's no means of releasing the tension on this. It's a pain in the arse. So it's undo these four. There's 4 of these on the plumber block, and then take the whole thing out somehow, which I think I'm going to try and do, because that's where the play is. You can see where the pulley's shifted along, and up to the other end there you can see where it's actually hard up against that, and you can see it moving. So, oh, pain in the arse. So now we're going to try and drop the pulleys off. Well, we got the counter shaft out. It's fitted on with a woodruff key in here, and then there is a flap for the grub screw to go onto. The grub screw wasn't very tight, and I have tightened it in the past. I'll probably fit it back together and put some drop a bit of Loctite down the hole for the grub screw. But it's obviously, I thought it was running key through, not a woodruff. Then we'll clean it up and put it back in. So got that all back on together. It's a bit tight and it's a bit of a pain getting to the bolts to tighten them up, but the noise has stopped. It's a 6-pole 1.1 kilowatt motor, ABB one. It's a bigger one than originally supplied, so this is I think the original was a 0.75 1 horsepower, I think that is, so we're 1.5 up. But it's a 6-pole, so it's got a lot of bottom end torque, so it doesn't have to run as fast. But I did have to change the pulley setup to get the gearing approximately to where it was. And at the time I did all that, I actually bought a new belt for that. I've just been having a look at the old one, and it's on its way. So I'd have been whipping off them pulley blocks anyway. So that's time well spent. It took a few hours. And I'm not going to run the lathe. I'm going to let the Loctite set up on that grub screw. Leave it now. If anything, it's just a little bit. I think I could probably move the motor over a little touch. It's a little bit hard up against this edge here. But then new bolt, it's got a bed in as well. Right. I'm happy with that. After a series of delays and unforeseen circumstances, we'll make it just setting up to cut the taper pin for the clapper box. So I've turned a blank. It's started out at 20mm diameter, and it's EN3, which is a fairly soft, mild steel. I've read what I could on what would be the suitable grades, and they seem to vary. Nothing as hard as EN8 and as soft as you like if it's in cast iron, if it's being used as a wear item. So I weighed up the clapper box and figured it'd be a lot easier making a new taper pin than machining out a worn hole once I get past the point where I can't ream it anymore. And given that I've already took quite a bit out on the reaming, I figured I'd make up a taper pin and then work on the basis of make that softer. So anyway, that aside, the advice was given was use EN7. Apart from the fact I couldn't find any, I've gone for EN3 because it's quite a soft, easy machining bit. So the first job I've done, set it up between centres. I've threaded the end with a 1/2 inch whip. That's a modification to the original spec because I want to have a nut on the end that I can just draw it in a bit. And when I've thought about the implications of that, I'll whiz over to the shaper. So it'll have a threaded section here. I've watched the likes of Steve Summers and a few others that have a nut on the end of it to draw the taper in. What I actually think it does is not so much draw the taper in, because if that hole's been reamed correctly and that, it ain't going to go in any more than it's in. What I do think it does is it's clamping, if you like, flexing the two side cheeks. So it's reducing the tolerance between the clapper itself and the box. That's my gut feel. Anyway, for the sake of sticking a thread on the end, I thought I'd make one and give it a go. So, I've made up a device, which is this, which is going to sit in the tail stock and allow me to do the offset. But I need to verify what the offset is. And for want of a better word, the very short length of bar that I got was actually bent. I took off about 150 thou now and took it down to I think it's nearly damn it 3/4 of an inch. In fact, I'll check it now. It's cooled down a bit. So that's 1,750. That's 1/2 thou under. So I've got what? Reading it round all the tenths. I don't even know if you can see that. Yeah, 6/10. So I've got 4/10 of a thousandth of taper between there and there, running between centres. I could probably piss about and get a bit straighter, but given I'm turning the taper, I don't think it's a matter. What I wanted to do was get something fairly adjacent all the way along, so that when I set up a DTI on the centre line and track it left and right whilst I'm adjusting this end, because I'm looking for a taper for 48 thou along, I'm coming this way a thou. Once I've got the taper I'm looking for, then clamp everything up and turn this end down. This end comes down to something around about 1/2 inch, and this end will be somewhere around about 5/8. Right, so my next problem is getting a DTI set up, because, and I'll bring you back in a second, I'll show you why I can't use that. So with the taper or tail stock taper set attachment, I needed to bring the tool forward, so I've elected to put a was it Jones and Shipman tool holder, which I don't use very often, to give me the clearance here. Now it's tight because I've got a set so that my what do you call it, drive dogs don't collide with anything. So that's where we're at. So the next thing I need to do is to basically have a DTI set up on the tool post, so when I traverse left and right I can measure the degree of offset, because whilst I've got a micrometer head on here, I need some means of, let's say, calibrating it, for want of a better phrase, because the length that it's pivoting over is going to determine the offset you need. Now if I measure between the 2 points where the centres are in contact, I wrote it down somewhere, can't remember what it was, but if I convert that into inches, the amount of offset the diameter change let me get that right. For the given length in inches, it works out to 131 thou change in diameter. So I'm over the length. So if I take half of that, half of 131 would be what, 65 and a half thou. So that's the offset. So if I set it at something in the region of 62, and then I can keep moving it across until I got the DTI doing what I want it to do. Well, that's the plan. So there's a 93 thou on the rim of that. And that's not looking good, so let's start that again. So that's on my 4.5 inch mark. So I'm at 83, so I need another 10 thou of offset. It helps if you don't crank up the bloody grub screws prematurely. 5, 10. Right, we're 2 thou under. So if we give it another 2. That's within a 1/4 thou. Anyway, because I've not done it before, I'm expecting to cock it up, so we bought a long section of steel bar to go at. So we're going to cut this and see how it looks. So that's the I have to make sure that's parallel with the bed, otherwise as you offset it, if it's on the piss, the centre is going to come up, which effectively is reducing the diameter. If it comes down, same thing again. So that's parallel. Got me offset, we'll give it a go. I haven't filmed the actual machining of it because it's not that exciting. I have had to piss about with the offset quite a bit, so I can get it in and out of the blank I've made, which is just a length of aluminium which I've actually stuffed the reamer down. I don't know whether you can see it, but the reamer is not brand new, and it's there's a bit of chatter in there. And we've got a bit of a way to go yet, but you can see it's starting to pick up, so we're approaching the actual taper that we need now, but we're not quite there. One of the things that's occurred to me is that where I was hoping that having set it up I could then make a couple, I can, but only if I make the blank length exactly the same and the countersunk on the end, so that the actual length over which that offset is has to be exactly the same. So it's not insurpassable, but it would be a shitload easier if the compound had pivot, or had actually made a taper turning attachment at the back. Still, you live and learn. So I've just took another 5 thou off the offset. Basically I came in too steep. Well, I've lost some footage because the camera ran out of battery, even with the cable in, because apparently you need to plug the other end of the cable into the wall. Anyway, I finished off the taper, got it so I was getting a reasonable print along its length on my piece of aluminium, and I've transferred it over to the clapper box. I've pushed the reamer through and cleaned it out until the point where I could feel the clapper box lifting as I tried to rotate the reamer. I've then gone in a little bit more just to make sure I've cleaned, made a nice clean hole from side to side. I've then taken the reamer out, lifted the clapper out, and then I've just put the reamer in, and I've given it basically, I suspect I've moved it about 2 thou that way in on the reamer, such that now when the pin's home, and it's only pushed home by hand, I can't feel any side to side movement, and it's rocking nice. So I got to clip the end off, tickle that up, make a washer up so that when I put the nut on, it's actually pressing on the side there, and hopefully that's it. It's been another educational project. Dog's grumpy because she's not been out for a walk today, but it's been raining. So that's the new pin fitted. I don't know how long the nut's going to stay on because it's only finger tight. That's clapping alright, and I can't feel any movement on it at all, side to side. So proof's in the pudding. I'll set up a cut and do some cutting with it when I've got the next job on, and then I can get back and start progressing my indexing plates for the gear cutting. I'll upload this because it's been a while. Ta-ta for now.